Hi, I'm Rob, and I'd like to welcome you to this video where we'll deploy a pre-trained and exported machine learning model to Docker using Kubernetes. Before we get started, I want to mention that this video picks up where the prior video in this playlist ended, training and exporting a machine learning model, then deploying on a Docker network. So if you'd like to see the details on how to train, evaluate, and make predictions on the model, as well as export it, feel free to check that video out. Also, we'll obviously be using Docker and Kubernetes in this video. So if either of these are new to you or you need a refresher, I have playlists on both Docker and Kubernetes that will get you up to speed to follow along here. Now, with that out of the way, let's get started. So in VS Code, the first thing I want to point out is the README file in the project folder. It points out that you obviously need Docker and Kubernetes installed and enabled, and that you need the joblib file for the trained model. Again, these were covered in prior videos. Under the build and deploy section, there are 3 commands you need to execute to deploy the model behind a fast API app with the Flask UI in Docker containers managed by Kubernetes. The first is the build and prepare shell script. So if we take a look at that, we'll see it's simply building Docker images from the API Docker file and the app Docker file, which we covered in the prior video, but we'll take a look at them quickly here. So the API Docker file uses a Python 3.9 Slim base image. It has an app worker. It's copying the API requirements text file and passing it to pip install. It's copying the API app, which is a fast API app, and the exported model. It's exposing port 8081 and then has a command to launch the API. Taking a look at the app Docker file, it's similar. It's using a Python 3.12 Slim base image. It has an app worker. It copies the appropriate files and does a pip install using the app requirements text file. It exposes the app on port 5001 and launches the app. So we'll close the shell script. And then the next step is to execute the kubectl command, applying the configuration files in the K8s folder. So looking at the K8s folder, we see a customization YAML file, which serves as a customized configuration file that manages and orchestrates Kubernetes deployments. In the file, we see we're defining a namespace called diabetes predictor, and it has 3 resources. The first is a namespace YAML file, which declares a namespace with the name of diabetes predictor. The second is the API deployment YAML file, which defines a deployment for the Pima diabetes predictor API. It indicates we want 2 replicas. It gives the container a name of API and specifies to use the Pima Diabetes API latest image and exposes support 8081. There's also a service for the Pima Diabetes Predictor API in the Diabetes Predictor namespace. Its selector is the Pima Diabetes Predictor API. It's exposed on port 8081 and is a type of cluster IP. And then there's the app deployment YAML file. This is similar to the API deployment YAML. Its kind is a deployment. It's for the Pima Diabetes Predictor app. It also has 2 replicas. The container name is app, and it's using the latest version of the Pima Diabetes app image. It's exposed on port 5001 and has a service for the Pima Diabetes Predictor app and is exposed on port 5001, and its type is node port. So after the images are built, and the resources are deployed using kubectl, we'll use the kubectl command to port forward the Pima Diabetes Predictor app service on port 5001. So let's open a terminal, copy the prepare shell command, but before we execute it, let's jump into Docker, and we see we currently have no containers, no images, except for the Kubernetes and Docker desktop images. So I'll just change this to Pima, and if we go to Kubernetes, we don't yet see our namespace. So let's jump back into VS Code and execute the script. If we jump into the right folder, now let's jump back over to Docker, and we see our images, but no containers yet, and no namespace. So back in VS Code, we'll execute the next command. Now if we jump back over to Docker, we see our containers and go to Kubernetes. We see the diabetes predictor namespace with our deployments, nodes, pods, and services. So finally, let's execute the port forward command and jump into a browser and go to localhost 5001, and we see our Flask app, which fronts the Fast API app, which interacts with our model. So let's scroll down and check the health of the API. And we see the API is healthy. So let's scroll up and we'll get sample patient data for a diabetic patient and then populate the prediction form. This is just so I don't have to type the information in, and we'll get a prediction, which will again hit the Fast API, which will interact with the model. And we see the prediction result is for a diabetic patient. Now we'll get patient data for a non-diabetic patient, populate the form, make a prediction, and we see a non-diabetic result. So this looks pretty good. Now let's jump back into VS Code, and I'll go ahead and stop the running process. And in the README, we see we can execute a teardown shell script, which will clean up our Kubernetes and Docker resources. So I'll copy the command and execute it. And then we'll check to see if there are any resources hanging around. And this looks pretty good. And we see there are no resources related to our Pima Diabetes Predictor app. So that concludes this very quick demo of deploying a trained model to Docker using Kubernetes. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content to the channel, please consider subscribing. Thanks for watching.